Hi everyone, welcome to Science 9. You've had a chance to see your pendulums a little bit and maybe get an idea of how they work. And that's what science is about. Science is trying to figure out how things work. When we use the scientific inquiry method, we're just trying to figure out how the world around us works. So when we have questions about how things are related or how things affect each other, we can use science to answer those questions or try to answer those questions. Now, we're getting started today with a pendulum lab. A pendulum is a pretty straightforward thing, and hopefully you've noticed there's not that many things on the pendulum that you can manipulate or change, and things that you can change are called variables, and we can change them, we can measure them, we can prevent them from changing, depends on what we're doing in our experiment. With a pendulum, there's really only three. A pendulum consists of basically an arm, and we're using a string for that, with a mass on the end of it. This thing's called a bob, and we can swing it, and we can let it go from up here, or we can let it go from down here. So when I say the angle of swing, that's what I mean. We can release it from this angle, or we can release it and let it swing through this whole angle. We can change how long the string is, and we can change how much matter we put at the bottom of that string. When you're about to do your experiment to see if any of those variables affect the time for 10 swings, you have to write a hypothesis. A hypothesis is not an educated guess. I know we've learned that in the past. It's incomplete. It is a testable statement based on your prior knowledge. So the based on your prior knowledge part is, yes, that's what we mean when we say educated, but testable is very important. A hypothesis has to be testable. That's what you do an experiment for. You do the experiment to see if your hypothesis is supported or rejected. It's totally okay if your hypothesis is rejected. In fact, usually they are. We learn stuff, we learn a lot from a hypothesis that is rejected. When your hypothesis is supported, there's still a whole lot more tests to do because we don't know if that's the only thing that's affecting our results. All right. When you write your hypothesis, you write it as an if, then, because statement. If I change one of these variables, then another variable will be affected because of something. And I'll show you an example hypothesis here. If I increase the mass of the bob, so this tells me what I'm changing. And you'll notice I didn't say if I change the mass of the bob. Change doesn't mean anything. Change can mean increase or decrease. I want to know how I'm going to change it. So if I increase the mass of the bob, then the pendulum will take more time to complete 10 swings because the extra mass will slow the speed of its swings. So I have the variable I'm changing, my if part, I have the variable I'm measuring, my then part, and I have why I think that, my because part. And those are the three parts of your hypothesis. It is important that when you're identifying your variables, you know exactly what's going on. And the variable you change is only one variable. If we change two or more things in our experiment, we wouldn't know what was causing the result that we measured. We would have confusion. So you only change one thing at a time. That allows us to see how it affects the result. That was the if part in our hypothesis. If we increase the mass, that was the variable we changed. The variable you measure is the then part, then the amount of time it takes to complete 10 swings will either increase or decrease, so that's what you're measuring. And then the variables you keep the same are the ones that you intentionally don't change. So if I want to know how only the mass affects the the time for 10 swings, then I'm going to prevent the length of the pendulum from changing, and I'm going to keep the angle from changing, which means I'm intentionally going to pick them. I'm going to make sure that the length of the pendulum is some length, 30 centimeters, and I'm going to make sure the angle I release it from every single time is always the same, maybe 10 degrees. That way, those things don't interfere with my results and I get good data. Now, when you're getting ready to do an experiment, you need to have a plan. We call our plan our procedure. It just tells us what we're going to do. These are detailed but concise. Your procedure is detailed enough that somebody else could redo your experiment without you telling them how, just from reading your procedure, but not a huge long document. So here's an example procedure. I will set up a pendulum with a string length of 30 centimeters. There's one of those variables, the length. I'm telling you what I picked it to be. The bob will have a mass of 50 grams, so I told you what my starting mass is. I will release the pendulum from an angle of 10 degrees. There's another one of those variables. And use a stopwatch to time how long it takes to complete 10 swings. So there it is, that's what I'm measuring. I'm timing how long it takes to complete 10 swings. I will repeat the experiment until I obtain 3 consistent trials. We're going to talk about that in a minute. Then the entire experiment will be repeated with 100, 150, and 200 gram bobs. So that tells me what I'm going to change. So I started with 30 centimeters, that never changed. I started with 50 grams, that will change. And I started at an angle of 10 degrees, that never changed. I always measure 10 swings, and I'm looking for 3 consistent trials. Now, why am I looking for consistent trials? Well, we do multiple trials to make sure our results are not messed up. So if we did this once and I timed 10 swings and I got a time of 16 seconds, and then I timed 10 swings again and I got a time of 30 seconds, that's a really big disagreement, and I don't know which one of those is valid. So then I time it again and I get like 17 seconds. That leads me to believe that the 16 seconds is probably good and the 30 seconds is probably not so good. We're going to do one more trial just to see, and if I get something like 15 seconds, then yeah, these 3 are in fairly good agreement with each other. This one's out, and I would not include that. I would probably say, oh, I forgot to restart my timer, or I miscounted my swings, but it's not a good thing. So we do multiple trials because we want to make sure we're getting consistent results, we're getting accurate results when we're doing our experiment. Now, you do have to have a way to keep track of all that data that you're collecting, so we have a data table. Data tables are a great way to keep track of your stuff, keep track of what you're measuring, what you're changing, and there's a nice, easy way to set them up. You have multiple columns. Your first column is going to be the variable that you change, and the rest of your columns are going to be the variable that you measured. And it takes multiple columns to measure because we're doing multiple trials. So here's an example data table. I have over here the variable I'm changing how much mass is on the end of my pendulum. So this says 1 washer, 2 washers, 3 washers, 4 washers. We're going to use probably 50 grams, 100 grams, whatever your mass is, and this could be angle, this could be length, depends on what your experiment is. Time for 10 swings, so I told you what I'm measuring over here, and then I have trials. I have trial 1 time, trial 2 time, trial 3 time, and then I'm going to change my mass, and I'm going to do the 3 trials again. Then I'm going to change the mass, I'm going to do my 3 trials again, and up until I've measured all the different masses. Then this last column over here is actually not something you record, it's something you calculate. That'll be in the analysis part of your lab. That's the average. Remember, an average is the sum of all your previous data, so trial 1 plus trial 2 plus trial 3, divided by however many there were. So this would be 1 plus 2 plus 3 divided by 3. Then you're ready to do your experiment because you have your procedure written up, you have your data tables ready to go, so now you need to start collecting data, and that's what the experiment's for. That's where you get your data. Then you'll do some analysis and your conclusion after your experiment.